Welcome dear students to the class of chemistry. Today we'll complete the remaining portion of chapter number 9, carbon and its compound. In the topic C, carbon dioxide. Today we'll now study the properties of carbon dioxide. So the physical properties are nature of the carbon dioxide, that is, it is a colorless, odorless, a very faint acidic sour taste gas. Means when you will dissolve carbon dioxide in water, it will give you acid H2CO3. Density, so carbon dioxide is 1.5 times heavier than air. Solubility, it is fairly soluble in water. Solubility increases with an increase in the pressure. Means if you are increasing the pressure, in that case more carbon dioxide can be soluble in the water. Liquefaction and solidification into dry ice. So carbon dioxide can be liquefied under pressure. Means if you will increase the pressure, then most of the gases will change their state from gas to liquid. And when liquid CO2 will be cooled at minus 78 degrees Celsius under normal pressure, it will convert into snow white solid, which is also called dry ice. It is called dry ice because it is having a solid texture and snow white color. This is the similarity with the ice which is formed from water. Otherwise it is having no similarity with the ice formed by water. So dry ice directly changes into gaseous carbon dioxide from its solid state without passing through its liquid state. Means it is a sublimable substance. We know that the substances which can be changed from the solid state directly to the gaseous state, they are called sublimable substances. So dry ice is having sublimation property in it. It is also having cooling effect. Now physiological action. Carbon dioxide is a non-poisonous gas, but in excess, if you are having this gas around you in excess, in that case it will cause suffocation. So a person may die in an atmosphere of carbon dioxide due to lack of oxygen. This is the simple phenomenon. So aquatic plants and animals use the carbon dioxide dissolved in water to prepare their food during photosynthesis. So this is the proof which proves that carbon dioxide can be dissolved in water. Now the chemical properties. So combustibility, carbon dioxide is neither combustible nor a supporter of combustion. Action on litmus paper. Since carbon is having acidic nature, so it will turn moist blue litmus to red. Reaction with water. Carbon dioxide dissolves in water and it gives us weak acid, which is carbonic acid. So CO2 plus H2O, it gives H2CO3. Reaction with alkalis. So first of all, we'll recall what are alkalis. The bases which can be dissolved in water, they are known as alkalis. So here we are having alkali NaOH and KOH, and when carbon dioxide reacts with alkalis, it produces salt and water. So these are the two salts respectively of NaOH and KOH, sodium carbonate and potassium carbonate. So when excess of carbon dioxide is passed through alkalis, we'll get soluble bicarbonates. So Na2CO3 plus CO2 plus H2O. It will give you 2NaHCO3, sodium bicarbonate, KHCO3, potassium bicarbonate. Potassium hydroxide or sodium hydroxide are used to remove carbon dioxide from a mixture of gases. We know that why they are used to remove carbon dioxide from the mixture of gases, because small amount of these alkalis can absorb large amount of carbon dioxide, as we have seen in these equations. Since alkalis are reacting with carbon dioxide and they are converting into salt and water. So potassium hydroxide is preferred as it has better absorbing capacity than NaOH. Now carbon dioxide when passed through lime water, it turns it milky. It will change the color of the lime water and it will turn into milky color. So this is due to the formation of insoluble calcium carbonate. We'll get calcium carbonate in the insoluble form, that is in the. So this reaction is used as a chemical test for carbon dioxide. Reaction with metals. So magnesium metal burns in presence of carbon dioxide to give magnesium oxide and carbon black. So 2Mg plus CO2, it gives 2MgO plus C. Reaction with metallic oxides, that is basic oxides. Carbon dioxide reacts with metallic oxides to produce metal carbonates. So you are having metallic oxide Na2O plus CO2, it will give you sodium carbonate, that is metallic carbonate. Metallic Na is metal here and CO3 is the carbonate. Similarly, magnesium oxide plus carbon dioxide, it will give MgCO3, magnesium carbonate. Reaction with non-metals. Carbon dioxide reacts with red hot coke to produce carbon monoxide, a highly poisonous gas. CO2 is not poisonous, but CO is a poisonous gas. So carbon dioxide plus coke, that is C, it will give you 2CO. Now test for carbon dioxide. One test is the litmus test. It will turn moist litmus into pinkish red. And if a burning candle or a smoldering matchstick is introduced in a jar of carbon dioxide, it will extinguish. So this proves that the gas is a non-supporter of combustion. So, and the third test is when carbon dioxide is passed through the lime water, it will turn the lime water in milky color, and when excess of gas will pass through the solution, milkiness will disappear. So this is the best test for carbon dioxide. Now, uses of carbon dioxide in aerated drinks. Carbon dioxide is used in manufacture of aerated drinks, which you call soft drinks, or there's like Coca-Cola, Pepsi, etc. So these gases are dissolved in water under pressure to give soda water. So when the bottle is opened, the pressure is released and the bottle gas escapes with a brisk effervescence that adds a fizz to the drink. So generally common soft drinks, as I told you, they are prepared by dissolving carbon dioxide in a sugar solution. And this gives a taste to the soft drink. Whenever you open the bottle many times, a soft drink bottle, when it is opened many times, in that case the whole carbon dioxide will escape from the drink, and in that case you always experience that the taste of the soft drink has been changed. And preservation of foodstuffs. Solid carbon dioxide is used as a coolant and refrigerant in ships for preserving food articles. If grains are kept in an atmosphere of carbon dioxide, they remain in good condition for a long period without allowing insect attacks. In hospitals, a mixture of 5% carbon dioxide and 95% oxygen called carbogen is used for artificial respiration. It is given to patients suffering from gas poisoning, pneumonia, drowning, etc. In the manufacture of fertilizers, so urea is an important nitrogenous fertilizer, and it is prepared when carbon dioxide and ammonia are heated at 150 degrees Celsius under very high pressure. In the preparation of chemicals, carbon dioxide is used to manufacture washing soda, baking soda, etc. In the baking industry also, it also used to dough rice, and it become the dough very light. So the baking soda is the mixture of potassium hydrogen tartrate and starch. So when the dough is having these particular ingredients in it, it will release. When these ingredients are mixed with the dough, they react and produces carbon dioxide. When this gas rises through the dough, spaces are formed and it makes the dough porous, light, soft and spongy. And this type of dough is used in preparing cakes and bread, etc. In photosynthesis, as you all know that CO2 is the main component during the photosynthesis procedure, while green plants are preparing food for them. In extinguishing a fire, since carbon dioxide is the non-supporter of burning and it is also a non-combustible gas, so it is used in the extinguishers to extinguish a fire. For a fire to occur, presence of a combustible substance and the supporter of combustion are required. If these two conditions are not satisfied, a fire will not be produced. So this principle is used for the firefighting purposes, and that is why carbon dioxide helps us to extinguish fire, because it is the non-supporter of combustion. Being heavier than air, it insulates the burning substance by cutting off the supply of oxygen, which is a supporter of combustion. We all know that to burn with a flame or to burn a flame, we need oxygen. Now the fire extinguishers. So fire extinguishers are devices in which carbon dioxide is produced in different forms to be used as an extinguishing agent. So here in this chapter, we will study about 3 types of fire extinguishers. First is soda acid fire extinguisher. Second is foam based fire extinguisher, and third is liquid carbon dioxide fire extinguisher. So the first one, soda acid fire extinguisher. It contains sodium bicarbonate and sulfuric acid in separate chambers. So it is having a metallic cylinder and its 2/3 part is filled with the saturated solution of sodium bicarbonate. A sealed glass bottle containing concentrated sulfuric acid is kept inside the cylinder. So when we use this extinguisher, so the cylinder is turned upside down, that is, it is in the inverted position and made to hit the floor. As a result, the glass bottle with the acid breaks and the two chemicals come in contact to react, and thus they produce carbon dioxide. We open the nozzle of the cylinder. With a great force, carbon dioxide gas is released from the cylinder and it spreads over the fire and cuts off the supply of oxygen to it, and hence the fire is extinguished. So the reaction between the sodium bicarbonate and sulfuric acid, it gives sodium sulfate, H2O and CO2. Now the next one is foam type fire extinguisher. So in the foam type fire extinguisher, we are having reactants aluminium sulfate and sodium bicarbonate in two separate chambers. When these two chemicals are made to mix with each other and they react, they produce carbon dioxide, aluminium hydroxide and sodium sulfate, which come out in the and the carbon dioxide and aluminium hydroxide together come out in the form of foam through the nozzle. So it is used to generally extinguish oil fed fires because the foam covers the oil as well as cut off the air supply to the fire. Here the reaction is given to you. So here in these figures you can clearly see the arrangement of the soda acid fire extinguisher and foam type fire extinguisher. You can clearly see these are the bottles of concentrated H2SO4, the glass tube, and here it is the aluminium sulfate in the glass tube. So whenever we have to use them, we just turn them inverted, we put them, we strike them to the floor so that the bottle or the tube which is present here, it will break down and it will react with the other components which are present here in these chambers, and they will produce carbon dioxide. So soda fire extinguisher cannot be used in case of an oil fire because the solution thrown by this extinguisher is heavier than oil. It will settle down in the particular vessel where the oil is spread all over here, so it will not work. So a chemical saponin is used to produce foam and sulfuric acid is replaced by aluminium sulfate. The next is liquid carbon dioxide fire extinguishers. So it is a modern and improvised type of fire extinguisher in which liquid carbon dioxide is stored in a steel cylinder under pressure. You can clearly see here, and when this pressure will be released, this liquid CO2 will convert into carbon dioxide gas, and in this way it will extinguish the fire. So the soda acid and the foam type of extinguisher cannot be used for fighting electrical fires. Why they cannot be used in electrical fires? Because in both of these fire extinguishers the solutions are prepared in water, so it will conduct electricity. So as a result it will generate an electric shock leading to a short circuit and another fire. So for the electrical fires and for the oil fed fires, in both type of fires we can use liquid carbon dioxide fire extinguisher. Since CO2 gas will be lighter, since CO2 gas is lighter than oil, so it will spread on the surface of the oil, and in the electrical fire also it is not having water component, so it will easily extinguish the electrical fire also. Now the carbon dioxide cycle. So the process by which the amount of carbon dioxide is maintained in the atmosphere, it is known as carbon dioxide cycle. So the percentage of carbon dioxide in the atmosphere is 0.03% to 0.04%, and it is balanced by the addition of carbon dioxide and at the same time by the removal of carbon dioxide from the atmosphere. So here you can see some factors or the methods or ways by which addition of carbon dioxide to the atmosphere can be seen, and here are some factors or the ways by which removal of carbon dioxide from the atmosphere is happened, so you can study them yourselves. The greenhouse effect and global warming. So the greenhouse effect and global warming, we all know that the trapping of Earth's radiated energy by carbon dioxide present in the air so as to keep the Earth warm is called greenhouse effect, and for the survival of life in any form on the Earth, this greenhouse effect is necessary. If this effect will not present on the Earth's surface, then the normal temperature of Earth will be minus 18 degrees Celsius. And at this low temperature, no one will survive. So we know that Earth receives heat energy in the form of radiation from the sun. And some of this portion is absorbed at the surface, and some of the portion of this heat energy is radiated back. So if these greenhouse gases, mainly the carbon dioxide gas, if it is present, then it will absorb the long wave reflected radiations and it will make the Earth hot. In colder regions, this principle is applied to grow plants of warmer climates in a house made of glass walls. So in those glass walls, since carbon dioxide is kept in it, and the glass allows the sun heat to enter the house, but it does not allow the trapped heat to move out of it, as glass is a bad conductor of heat, and thus this glass home is sufficiently warm to help to grow tropical plants. So this glass house is popularly called a greenhouse, and that is why we have given this effect greenhouse effect. So a question is given in your book that why does a closed car parked in the sun becomes unbearably hot inside? So all of you know that since it acts like a glass house and it trapped all the heat energy which is coming into it. So the temperature of the car is increased to a high temperature. Now due to air pollution, the total amount of carbon dioxide in air has increased, and that is why this greenhouse effect is also increasing. The other greenhouse gases are nitrous oxide, ozone, chlorofluorocarbons, methane, etc. So all these gases have created a thermal blanket around the Earth, and which is trapping more heat, and it is increasing the greenhouse effect. So when this increasing greenhouse effect is known as global warming. Now the cause of increased percentage of carbon dioxide in the atmosphere. The first is deforestation or cutting down of vegetation. Since human activities contribute to the accumulation of CO2 in the atmosphere, these plants if the plants are in the excessive number, they will absorb more carbon dioxide during the photosynthesis procedure, and in this way plants will reduce the amount of CO2 in the atmosphere. The second one is the air pollution due to industries, burning of fuels, use of chemical weapons, etc. Now the effects of global warming. So all we know that what are the effects of global warming. The first is that the scientists are predicting that the average temperature of the Earth will rise by 0.5 degrees Celsius in the past 100 years. The ice in the polar regions, it is also melting, and it is causing flood in the coastal regions and islands. The Gangotri glacier in the Himalayas already started melting, and it will bring flood to the northern plain areas in which we are also living. So a disturbance in the ecological balance, it will be seen, and it is causing. So a disturbance in the ecological balance is also seen. It could result in wide-ranging effects on rainfall patterns, agriculture, forest, etc. There will be extinction of many species and plants, many species of plants and animals, and in this way there will be the change in the crop cycle also, and in the weather cycle also we are also experiencing change now. The steps to balance carbon dioxide in the atmosphere. Since we all know that the greenhouse effect is now increasing due to the accumulation of greenhouse gases in an excessive amount, so the global warming effect is also increasing. So here are some steps we can take to balance the carbon dioxide in the atmosphere. By growing more trees and plants, reducing the consumption of fossil fuels, using smokeless sources of energy like solar energy, biogas, wind energy, etc., and using filters in the chimneys of factories and powerhouses. Our next topic is carbon monoxide. It's also a carbon compound. The molecular formula of carbon monoxide is CO, and its relative molecular mass is 28. Because the atomic weight of C is 12 and of oxygen is 16, so 12 plus 16 equals to 28. Now the occurrence. So carbon monoxide generally occurs in coal gas, volcanic gases, tobacco fumes, chimney gases, and in the exhaust gases of automobiles. It is present in the trace amounts in the exhaust gases of automobiles because majorly the components are CO2, NO2, NO, etc. Formation of carbon monoxide and its addition to the atmosphere. So when carbon monoxide is a product of incomplete burning or combustion of carbon and fuels. when you are giving a excessive amount of air or oxygen during the burning of carbon or the fuels, because the fuels like petrol, diesel, etc. contains carbon and hydrogen in them. So during the combustion of carbon or fuels, if excessive air is there, then the formation of CO2 is happening. And when there is a limited supply of oxygen, in that case carbon monoxide is formed. So 2C plus O2, heat is required for it, so 2CO, not incomplete burning of fuels. So generally carbon monoxide is formed in the domestic and industrial ovens where we are using coal, coke, charcoal, etc. So there with carbon dioxide, carbon monoxide is also formed. Generally in the industrial ovens, excessive amount of air is present where carbon at the lower end burns to produce carbon dioxide. When this carbon dioxide, as you can see in this diagram here, when this here coke is burning at the carbon is burning at the lower end of the oven, and we are inserting or producing air from these two inlets, here carbon is burning. When here carbon will burn, it will produce C plus O2 CO2. Then the smoke of this carbon dioxide will pass through this piles of the coal present here in the oven, and when this carbon dioxide will pass from this coke layer, it will convert to 2CO, because here amount of air is limited between the layers of coke. So carbon dioxide will convert to carbon monoxide, and at the top of the oven, this carbon monoxide in the presence of air, because here excessive air is present on the surface top of the oven, so this carbon monoxide again converted into carbon dioxide. Carbon monoxide burns here with a blue flame in the presence of oxygen, and it gives carbon dioxide. Now the exhaust gases of automobiles. So in automobile engines, generally we use petrol and diesel as a fuel. As I had told you that both the all the fuels mostly contains carbon and hydrogen in them. So when they burn within the engine of any automobile, there is a limited supply of air, and so carbon dioxide is also carbon monoxide is also formed with carbon dioxide, but in a very little amount. So here the definition of fuel is given. You all know about fuel. I'm not going to describe it here. Now the properties of carbon monoxide. Carbon monoxide is a colorless gas. It is tasteless and neutral gas, means it is not having any acidic, neutral gas means because it is not having any acidic or basic nature, and it's having a faint odor, but it's a highly poisonous gas. If we will inhale in a little amount, then we'll feel suffocation. It's very sparingly soluble in water, means a little amount of carbon monoxide dissolves in water. It's not fairly soluble in water like carbon dioxide. It's thermally stable gas, that it does not decompose at even high temperatures. It is a combustible gas, but it is a non-supporter of combustion. Carbon monoxide is poisonous. You can guess that how much carbon monoxide is poisonous, that if you are inhaling the air and in that particular amount of air, if 0.5% carbon monoxide by volume is inhaled, death can result. Okay, so 0.5% is a very little amount, and carbon monoxide is too much poisonous. That's why it results into death. And the reason is that when we inhale carbon monoxide, the carbon monoxide present in our lungs react with the hemoglobin present in our blood, and it forms a compound called carboxyl hemoglobin. It's a stable compound in our body, and it does not allow hemoglobin to absorb or carry oxygen. Thus our lungs, our body organs, respiratory organs, all are paralyzed, and it results in death due to suffocation. Now the harmful effects of carbon monoxide. So first is the sleeping in a closed room with a coal fire burning. So what happened? It is very dangerous to sleep in a room. Generally in newspapers you have heard that during the winters, complete family, the whole family died due to the inhalation of carbon monoxide gas, because what they do at that time, they put coal fire, burning coke in their room to make their room warm. And in that case, carbon, since all the doors and windows are closed of the room, and in that procedure limited amount of air is present in the room since all the doors and windows are closed. So what happens is after some time carbon monoxide is forming in the room, since it is not having any odor, so person cannot during the sleep cannot recognize that he is inhaling carbon monoxide, and slowly when this inhalation continued, in that way his body is deprived of oxygen and he died in the sleep. The person will not wake up during all this procedure, because slowly your bodies, your organs are paralyzed, and firstly it will attack on your mind. So you will be like in a coma if you are inhaling carbon monoxide continuously. So that is why it is also known as silent killer. Now the next is starting a car engine inside a closed garage. So in the engine of automobiles, due to the incomplete combustion of motor fuels, some traces of carbon monoxide is also present there. Therefore, it is not advisable to start a car engine inside a closed garage, because more of carbon monoxide could thus be produced inside a closed area, increasing the risk of poisoning. Remedies for carbon monoxide poisoning. So first is that the victim should be immediately brought out into the open. Second, the victim should be given artificial respiration with carbogen. And at places where carbon monoxide concentration is on the higher side, the people should wear gas masks that absorb carbon monoxide and oxidize it to carbon dioxide. Such masks are made of hopcolite, and hopcolite is a mixture of metallic oxides. Now the reducing action of carbon monoxide. Carbon monoxide is a strong reducing agent. It reduces and oxidizes it reduces the oxides of the less active metals to their respective metals, and itself get oxidized to carbon dioxide. As you can see, CuO plus CO, Cu and CO2. So CuO is reduced to Cu and CO is oxidized to CO2. Similarly with PbO plus CO, Pb plus CO2. Because of its reducing action, carbon monoxide is used as a reducing agent during the extraction of pure metals from their corresponding ores. So here we have completed chapter number 9, carbon and its compounds. If you are having any doubts, any problems, clear them in the doubt session on Zoom class. Till then, take care, goodbye, have a nice day.